Moving on now, I want to talk about one remaining issue when implementing your LMS, and that is how to test it. Testing is a critical component of any software development, and when you're testing software that dynamically generates database queries and is connected to a real database, there are interesting and unique challenges. So you've all learned about the various different kinds of testing strategies and philosophies. These are not mutually exclusive though, so unit testing in particular is a technique for writing and running small tests that can be used to implement some of these other forms of testing. So you can do black box unit testing, you can do regression unit testing, and unit testing is just a very common and popular way of executing and writing tests. So we're going to look at unit and regression testing in the context of a database controller, that is some method that generates a query and then looks for and then returns some result or has a side effect of modifying a database. The good news is that we're using MVC and we can actually test our controllers, and that's one of the main reasons to use MVC. So normally when you're writing software that has a UI component, a graphical UI component, it would be difficult to test because you would need someone sitting there with a mouse and keyboard and just interacting with the UI in order to invoke the various methods. But that's one of the main points of MVC is the controllers are a separate concern. They're just methods that we can call. So we can just call them separately instead of relying on a button click to call them. So as an example, let's take a look at the library web server, homework 6. Here's one of the controllers, checkout book. And normally this would be invoked by clicking on a button on the web page. But this is just like any old method. We can just call checkout book from a unit test. We can just invoke it directly without any button clicks. Just pass in some serial number, and then the method would run, and then our unit test could do some assertions and verify some result. But that brings up the next question is, what would such a unit test look like? So here's an example of a C# unit test. You can just invoke homecontroller.checkoutBook, give it some serial number, and then the question is, what do you assert? How do you verify that checkout book worked correctly? You could do something like write another query that queries the database and makes sure that serial number 1005 is in the checked out table or something like that. But this is where the challenges start to arise when testing software that interacts with the database. The first problem is tests have to have a known outcome. So we need to know what to assert against. We need to know that after running some code that the result is X or some fixed known answer. But if the result depends on querying a database and that database is constantly changing because people are using the system, you know, say this is the library and patrons are checking out books, returning books, things like that, then how do you know what the query should return if the rows are constantly changing? So how do you know what to assert against? The other problem, and it's related, is that unit tests should not affect the live system that users are seeing. So users of the library should not see books becoming available and unavailable rapidly just because your unit tests are running and checking out books and then returning them. So how can we address these problems? We'll look at a few ways. The first possibility is we could make a separate database that's just for the purposes of running tests against, and then we don't affect the live database that people are currently using. The test database has to have the same schemas as the live database in order for your tests to mean anything. And you would have to reset the test database to some known state before running the test suite, because your test suite is going to change the database potentially. You know, some of the controllers are going to update, delete, or insert rows. So if you run your unit tests again, it has to be back into some initial state so you know what to compare against. The downsides to this method are the test inputs are now no longer visible in the source code for the unit test. Normally, you write all of the code that sets up the test just right there in a unit test, so you as the reader and writer, you know exactly what the test is doing. But if the inputs are coming from some database that's elsewhere, then you would have to go look at that database to see what the initial state is and what you might be able to assert against. And it's harder to read and write tests. The other downside is that unit tests should be fast because there are going to be a lot of them in a realistic testing suite. And you want to encourage your developers to run them as frequently as possible as they're writing code. By inserting a slow database access over the network into a bunch of your unit tests, you're just going to slow them down and thus discourage people from running them. Another possible solution is to separate the database access from the controller logic. So you would write helper methods. Essentially, you write one method that does the database querying and one method that performs some kind of logic on the result of that query. And then you wouldn't unit test the controller itself, you would just unit test do logic. And you could generate fake inputs to the do logic part so they don't have to come out of a real database. This is my least favorite possible solution, and the biggest downside here is that you're now no longer testing the LINQ queries themselves. You're only testing the remaining logic parts. And sometimes there's not really even any logic to test. Sometimes all you want to do is the LINQ part. And this just kind of forces you to write your controller in a certain way, and maybe it's not really possible to separate the query part from the logic part. So this one we won't really give any more interest to. We won't look at it any further. The third possible solution is to use what's called a mock database that resides in memory on your own machine, and you don't have to go out to a server. And so what you do is you connect LINQ to this in-memory database instead of connecting it to real SQL. So what do I mean by connecting LINQ to something else? Well, that's one of the great things about LINQ is it's a general language for writing queries, not necessarily SQL queries. It looks like SQL, but it's not. And as part of what you get out of a scaffolder is you get something called a connector. So when we run the scaffolder on our MySQL database, it gives us all the tables, and it also gives us a connection string saying, here's the server, here's my username, here's and so on. Here's the database I want to use. And that connector is what tells the system how to translate a LINQ query into an actual database query. So there are connectors to SQL Server, there are connectors to Oracle database, and they take the same LINQ query and just compile or translate it into a different actual database query. So there is a connector for translating a LINQ query into something that just goes into a mock database instead of an actual MySQL database. So all we would need to do is go and change the connector that our scaffolded classes use, and then our LINQ queries will go and use a mock database instead of a real one. The downside to option number 3 is the only real downside I can think of is that we're now not testing with a real server connection. So things like timing, if timing is important or matters in the controller, then it's obviously going to be a lot faster with an in-memory mock database than it would with a real server connection. If there are race conditions or something, then timing can affect whether or not the race condition actually shows up and whether you know about it. But at some point, you just kind of have to trust that the mock database connector and the MySQL database connector are both going to work correctly, so you can write all the same LINQ queries and test them and just assume the connector will work, which is generally a safe assumption. And if it doesn't, that's kind of not really our problem anyway. We're not testing the LINQ connector. If it doesn't work, then we have bigger problems. So the idea behind mocking, as I've already kind of said some of this, is it's not a real MySQL server, but it does have to have the same schemas as the real database. So there's some data structures that the system automatically generates that emulate the tables that would go into the actual database, but they're just sitting there in your own computer's memory. It works with, here's the big thing here, is it works with the exact same LINQ queries. You just point them to a mock database instead of pointing them to a real database. But all of the scaffolded classes are the same. You can use all of the same controllers, all of the same code. The only one slight difference is you just configure it to connect somewhere else. The mock database is usually small. It has to be because it's residing in memory. So you can't really test queries where the point is you want to test how well it will run when there are, say, billions of rows. You would just have to do that with a real database if that's the kind of test you wanted to perform. One big thing to note here is the mock database is not necessarily an SQL compatible database. It's going to be LINQ compatible, it has to be, but turns out the one we'll be using in C# is not even a relational database, which means it will let you violate referential integrity, meaning foreign key constraints will not be upheld. But we will test that in a separate way. So it's still very useful to use a mock database as long as you create the tables with the appropriate referential integrity and foreign key constraints, then everything should be fine. So what I recommend for the full testing solution is use a mock database for all of the query and logic testing in the database controllers, in the MVC controllers. And then you should actually use a test database, so a real MySQL database, not the live one, but a test one, for the purposes of testing things like, make sure that referential integrity is all set up correctly and make sure that the LINQ SQL translation is working correctly. And the good news is you only have to run those SQL tests when the schema or queries change, which is rare. Normally you're mostly just changing something about the logic in the controller. You get the query right once, and then it's just right. And then you can go and change the controller code a bunch and just rerun your mock database tests. You don't have to go and rerun the tests on the actual MySQL test database if nothing there has changed.